So today we are going to do the 3D figures. Okay, so you are going to work with 3D figures. It's the same thing as yesterday. Yesterday we were working with 2D. We were finding the composite figures, the area or the surface area of it. Sorry, the area or the perimeter. Today we're going to work with volume and surface area. Okay? Because remember with 3D it's volume and surface area, whatever you're finding the measurement. So calculating volume for composite figure, as we did yesterday, you need to calculate the volume of each part of the composite figure object, add the volumes, and then subtract the volumes by the parts that are removed from the object. Okay? So it's the same idea. You're finding the separate ones and then you're adding them together or subtracting. So the first example says a machine bales hay in cylindrical rolls. For storage, a shrink wrap protective cover is placed in the bale. Determine the volume of hay in the bale and the area of the shrink wrap covering. So the question here is asking you for two things. It's asking you to determine the volume and to determine the area that wraps the shrink wrap covering. Okay? So you have to find the volume first, and you have to find the surface area. Okay? Because to remember, for 3D figure, the area is the surface area. Okay? So what kind of shape do I have? A cylinder, right? So for a cylinder, what's the volume of a cylinder? What's the formula for that? Yeah. Pi r squared h, right?
Yeah, I squared.
Alright, so to determine the volume, I have to do pi times r squared times h. Now let's look at the shape that I have. They gave me 5 feet, and that is what we call this. Diameter, right? So I can't use that because the formula says radius. So what would be my radius?
The half?
The half of that, so that's 2.5. Okay? And then 6 feet is your height. Okay? So I can place this in the formula. The volume equals pi times 2.5 squared times 6. You have to enter it in the calculator properly because it's only 2.5 that is squared. Okay?
It's 117.80.
8.
80972.
Okay, so that is feet cubed. Right? Because the volume is in cube. Is unit cube. Now to solve for the surface area, what is the surface area of a cylinder? What's the formula?
Formula. Base times height times length.
Not for a cylinder, no.
Oh, no. Oh, yeah.
So what you're looking for? The area?
So if you look right here, the surface area is the 2 pi r squared plus 2 pi r h. Okay. So again, you just have to fill in the information. So you have to replace the radius with 2.5, and then you have to replace the height with 6.
Just the last idea I didn't get it.
What?
The last idea I didn't get it. Why we add that area surface area to that?
Because the whole surface area of the cylinder is this formula.
Okay.
So it's the area of the 2 circles,
Alright.
right? Which is this one and the bottom one, and then the area of the lateral face,
Okay.
right? So this is the area of the 2 circles, the 2 pi r squared, and then the 2 pi r h is the area of the lateral face. Okay? So the answer for this would be 133.5. Is that right? square feet. Are you guys okay with this? So far is knowing which formula to use, right? And then plugging in the correct information in the correct letter. Can someone confirm the answer for that one? Yeah?
No.
Okay. Now the second question is asking you, how much shrink wrap is needed if the wrap does not cover the end of the rope? So what would the shrink wrap be covering?
The outside of this one.
The outside, which is what part of the outside?
Area.
Hmm?
No, sir, yes.
So, think about this. As your cylinder that you see, right? So how much shrink wrap is needed if the wrap does not cover the end of the roll? So what is it covering? If it's not covering the end of the rolls, what is it covering? What do we call this face? The lateral face, right? It's not covering the two circles, right? It's not covering the ends. It's only covering the lateral face, right? So what part of the formula then am I looking at?
That's the lateral surface, 2 pi RH.
2 pi RH. That's right. Okay? So I'm looking only at this part of the formula now, right? Because that's the surface area of the lateral face. If you go back to your notes, it tells you that area of the lateral surface is equal to 2 pi RH. You see it? That's the only thing that I need to look for in the second part. And remember, the units for surface area is units squared. Now suppose the shrink wrap is priced and sold by square meters at $0.75 per meter square. How much would it cost to cover the bale in part B?
Two pi r square.
We have to convert feet into meters.
Okay, number one, they gave me the price in meters squared, dollar per meter squared. My units are feet squared, right? So I can't do that. I have to convert feet to meters squared so I can find the price. But what am I trying to find the price of what? The cover in what part?
And the part B,
In part B, right?
which is B.
So which is covering only the lateral surface, right? So I'm looking at how much would it cost me to cover this surface, right? I know that this surface is 94.2 square feet, right? So I want to know how much would it cost me to cover that, okay? So the first thing I have to do is I have to change that into meters squared because my price is in meters squared. And then I have to do my multiplication. Okay? So if you look at in your green bulletin, right? I probably don't have feet to meter,
Yeah, you do.
but I have feet
Yeah, you do.
squared to meter squared. I mean, I do have feet to meter. Okay? So I'm gonna have to use that. But remember, what do I do if 1 feet equals to 0.3048 meter? What do I do to make it squared?
0.7.
I have to put the square on. I have to square each of them. Remember, because this is squared, this is squared, so I have to square it. Okay? So that will be 1 square feet equals to,
Only one square feet.
what's 0.30 squared? 0.09. Can you guys confirm that number? Yeah, 92903. Okay, now I have 94.2 square feet. Where do I put that? The 94.2 square feet, where do I place it? Under the feet square. And now what do I do?
Cross multiply.
Cross multiply. I forgot to put the units. What do you get? 8.75? So that means I need to cover 8.75 meters squared. How much would that cost? What do I do? Multiply by the price. Right. So when you buy, you probably can't buy 8.75. You have to buy like 9 meters. So we're gonna say it's approximately 9 meters. This means approximately 9 meters squared. So that squiggly line, the squiggly equal means approximately 9 meters squared. So therefore the price
6.75.
would be 9 times 0.75, which is
6.75.
$6.75. Okay? And remember that I haven't been putting a therefore statement, but you should be putting a therefore statement. So you have to put therefore the price to cover the mail in part. B is $6.75. Okay, so understanding what the question is asking you for and knowing which formula to use is very important. Making sure that your units match is also very important. All right. Are you guys okay with this?
The 0.092.
Yeah.
Where does it come from?
If I square, if I put 0.3048 to the power of 2,
Okay.
then that would give me. Okay? complicated question here. That was not complicated, no. Compared to this,
Wow.
the other one was not.
Meaning?
Okay, so most of the time when you're talking about when you're doing like construction or when you're doing a renovation or whatever, you are doing it without you knowing that you're actually doing it. Okay? Are you doing it correct or are you doing it wrong? I don't know, but this is a nice way. Okay. So calculate the surface area. To calculate surface area of a composite figure, you have to calculate the surface area of every side, right? And or every figure, and then you have to add them all together. Okay, so we've been talking about that previously, so it's nothing new. So what do we have here? What do we have here?
It's not clear.
What do we call this?
Taylor room?
Oh.
Shed.
It's a shed.
Oh.
It's a shed,
Shed.
right? It's a kind of like yeah, a shed. It has different figures in it. It does have a rectangle. It does have a parallelogram. It does have a triangle, right? It has different forms, different shapes. Now, the first question is asking you to calculate the volume, determine the volume and the outside surface area of this shed. And they want you to find the volume in cubic meters. Now, what is my unit in centimeters? So if I find the volume of this shed, what is my answer going to be in?
Centimeters squared.
Centimeter cubed,
Or
because
cubed,
it's
sorry.
volume, right? So I can wait until the end and then get the answer in centimeter cubed and then do my conversion. Or I can do my conversion early on and then that I would end up with the answer of meter. Yes.
Wait, what's the difference between squared and cubed?
Cubed is used for the volume, right? So the volume would be meter cubed. Okay? Because when you're doing volume, let's say you're doing length times width times height, right? So meter times meter times meter, that gives you meter cubed. Okay? That's why it's cube. All the volume is in cube, right? When you're talking about surface area, you're doing length times width. There's no height, and that would be meter times meter, so that's meter squared. Okay? You see the difference between the two? So anything that deals with area is squared. Anything that deals with the volume is cubed. Okay, so if you're looking at the 3D shapes, there's two 3D shapes here. What are they? There's two 3D shapes.
Rectangle, or triangle and rectangle, or trapezoid and rectangle.
That triangular prism, right? So if you look at this is a triangular prism. Okay? So if you look at the pink sheet, if you look at the bottom one, right? It looks like this, but sideways, right? So it's sideways. So that would give you the top part, right? And then what's the bottom part?
It's
Prism. That's right. It's a rectangular prism. So if you look right here, rectangular prism, which is this one, and then the top, which is the roof, is your triangular prism.
you flip it, gotta be the same.
Yeah, exactly. If you flip it this way, it will be the same. Okay? Now, so we have two shapes. I have to find the volume of the first one, the volume of the second one, and I have to add them. Okay? I'm not going to do the conversion until the end. All right? So let's look at this. So the volume of the triangular first. formatting, so like. It's equal to base times length times height divided by 2.
You are taking which formula for triangular prism or?
Yes, the triangular.
So,
Do you guys see that? Alright.
this one for the complete triangle, the one besides it's a half triangle, right?
Which one, sorry?
Half BH.
It's the same thing. BLH over 2 is the same thing as half BLH.
Oh, right.
Okay? They're the same form. Okay? So if I'm gonna look at this, the triangular prism right here. Let's see which one is B and which one is L and which one is H. So B is the base of the triangle, right? So B is the base of the triangle. So that's your B. Okay? Your L is the kind of the altitude of the triangle. So it's this. Okay? If you look at H, that's the depth of your shape. So that's gonna be H. Okay? So it's knowing which side are we looking at. Very important. Okay? So B is 310. L is 79. Right? Because you see that it's giving me that right here. And H is 289.5. And the unit is centimeter cube. The second shape is the rectangular prism, right? Which is the bottom. So if I look at the rectangular prism, it says the volume is length times width times height.
Can we write the centimeter cube with 2.8, not 0.5? Or it's necessary?
Well, it's okay to write it as 2.8 because at the end you're gonna have a much smaller number in meter cube. So for the rectangular prism, this is the length. Doesn't matter which one is length, which one is width. So I'm gonna call this length, width, and height. Right? So that's gonna be 310 times 289.5 times 202, and that is equal to 21673,417.5 cent. No, another one. Should be 18128,490 centimeter cubed. Okay? So now to find the volume of the whole thing, you have to add both of them. remember that I want it in meter cube. So to go from centimeter to meter, right? Go back to your purple sheet. To go from centimeter to meter, you have to divide by 100 because I'm going up and I'm going up 2 steps from centi to meter. You see that? So look here. So from centi to a meter, I'm going up and I'm going up 2 steps. So that means 100. Divide by 100. Okay? So every 1 meter is equal to 100 centimeters. Right? Now I don't have meter and centimeter. I have meter cube and centimeter cube. So what do I have to do?
Times by.
I have to cube it.
Okay.
So that's going to be 1 meter cube equals to, what is that? 100 centimeter cube. Too many zeros. 1 million. Okay. Now if I place my answer under the meter cube, under the centimeter cube. Cross multiply and divide, so I'm dividing by 1 million. So your answer should be 21.67 meter cube.
Here I have confusion. I don't understand. 1 meter cube is equal to how did you find it?
How did I find it equal to 100?
Yeah.
1 meter is equal to 100.
Yes.
You're okay with that? So cube this is 1. Cube this is 1 million. So put it to the power of 3.
Okay.
Power of 3.
Okay.
Okay. Are you guys good? Can I? Now again, this is the easier part. Now, if I'm looking for the surface area of this shell, okay? So the surface area is the area of all the sides that you can see, okay? So I can't use technically these formulas, right? Because these formulas, let's say if I'm looking at the surface area of the rectangular prism, it's going to give me the surface area of the top, the bottom, the sides, and the sides. Okay? if I'm looking at this specific shape, my top is not there. The top of that prism is not there, right? So I can't account for it because I have a totally different shape for that top of that rectangular prism, right? The bottom of that shape also is not there because I'm using the ground for it. So technically I can't use these formulas per se. I have to go and see how many faces do I have? What are they? And find their area specifically. Okay? Then add them all together. Add. Okay? So let's kind of let's split this. So if I'm looking at this shape, let me take a picture of it. Alright. This pattern. What do you see? Just look at the roof. How many rectangles do you see? In the roof.
Rectangle?
Two. The rectangles actually. You think they are over, but they're actually rectangles. So I see two rectangles, right? So I see this, right? And then the same one on the other side, right? Good. So we see two rectangles for it. Now, what's the formula for a rectangle? Length times the width, right? So it's this times this, right? I know the length, correct? Which is 289.5. Do I know the width? No. So I need to find that first.
Like we do have height, we do have height, so we can half it.
So we have height.
Divide it with 2.
Divide what with 2?
Because we do have 202 centimeter of height of the whole shape.
This is 2, yeah?
Yeah. So we have to divide it by 2.
Divide what by 2?
Okay, this is width and no, width is 79 of rooftop.
So the 79 is this.
Yes.
Yeah.
Okay.
What's my width though? What is this?
This is half part of the, subtracted.
No. I have to use Pythagorean theorem.
Oh my god.
You see this triangle right here?
That's right angle triangle.
Right? I know this is 79. And this, because of the symmetry, right? This is a isosceles triangle right here, right? So if I put the height, if I bring down the height, it's gonna cut this side in half because of the symmetry. So this is gonna be 310 divided by half, so that's gonna be 155.
Why
Okay?
divided by half?
Because the whole thing is
Okay.
310. Right?
That's simply-
If I'm putting an altitude, if I'm bringing an altitude down, which is 90 degrees, right? Because this is an isosceles triangle, it's gonna cut this in half, okay? And it's gonna become 155. So I have a right angle triangle with two sides, and I'm looking for the hypotenuse.
For C.
Okay? So I'm gonna do this right here. I found that side, right? Now I know the length and the width, so I can write the formula for it. Okay? So I have the formula is length times width. I'm gonna use, okay, instead of these letters, I am going to use, okay? So for this one, I'm going to use W. I'm gonna use S for this side. Where I'm still doing the same thing, I'm multiplying this times
So what does S represent?
this. It's the slant, it's a slant side, okay? Just because we're gonna be using length a lot, so. So this is basically the area of this rectangle, right? And on the other side of it. So the area of the two rectangles of the, are you guys okay with that? So the roof panel, we see two rectangles, and we also see how many triangles? Two triangles, right? So we see triangles right here. Right? And the one at the back. Okay? So two triangles, and the formula, the area of a triangle is base times height divided by 2. That's the area of a triangle. Base times height divided by 2. So this is the base, this is the height, right? And then I'm gonna have to divide that by 2. So 310 times 79 divided by 2 is equal to, and then I have to multiply by 2, right? Because I have two of them, right? I have two triangles. And then multiplied by this, so basically they're gonna cancel each other. And then you're gonna end up with 24,490 centimeters squared. Are you guys okay with that? Yeah?
Because we're looking for 2, so we have 2 in front of them.
That's right, because I have 2 of this. Then for my rectangular prism, I have the front and the back, they're the same, right? And then the front and the back, they're rectangles, so it's length times width. So it'll be 2 times 310 times 202. And last but not least is the sides, right? So it's also 2 of them, length times width, and that would be 2 times 289.5 times 202, which is equal to 116.95. Are you guys okay with this so far? So you see how I'm splitting my figure into different shapes? Now what I have to do is I have to add them all together, and then at the end I have to convert to meter cubed. Okay? So if I add them all together, I'm going to end up with 3 centimeters centimeters squared, not cube, because that's area. Okay? We know that the conversion is every 1 meter equals to 100 centimeters, right? I have to square that. So every 1 meter squared equals to no, it's squared because that's an area, right? Cross multiply and divide. Can you guys do 100 squared for me?
10,000.
So it's 10,000. So one less zero, right?
100 square, right?
So it should be this. 5.